Download this code from codegive.com, link in the description below. OK, let's dive deep into browser caching, a crucial aspect of web development for performance optimization. This guide will cover the fundamentals, different caching techniques, common headers, strategies, and best practices, along with code examples in various server-side languages. A web developer's guide to browser caching, supercharging your website's performance. Introduction: Why browser caching matters. Browser caching is a powerful technique to significantly improve the perceived and actual performance of your website. It works by storing static assets, images, style sheets, JavaScript files, fonts, etc., in the user's browser after the first visit. When the user revisits the page or navigates to other pages on your site, the browser can retrieve these assets from its local cache instead of downloading them again from the server. Here's why browser caching is essential. Reduced latency. Serving assets from the cache is dramatically faster than downloading them over the network. This leads to a snappier, more responsive user experience. Lower bandwidth consumption. By reducing the number of requests to your server, you save bandwidth. This is particularly beneficial for users with limited data plans. Reduced server load. Less frequent server requests translate into lower server load, allowing your server to handle more concurrent users. Improved SEO. Website speed is a ranking factor in search engine optimization, SEO. Faster websites tend to rank higher. Offline access. Partially when set up correctly, caching can allow some elements of your website to function even when the user is offline. Fundamentals of browser caching. At its core, browser caching is a negotiation between the browser and the server, governed by HTTP headers. The server sends headers that instruct the browser how long to store the asset, how to validate it, and under what conditions it should be refetched. 1. The caching process. First visit, cache miss. When a user visits your website for the first time, the browser makes requests to the server for all the necessary assets, HTML, CSS, JavaScript, images, etc. The server responds with the asset content and HTTP headers that define caching behavior. Caching. The browser reads these headers and stores the asset in its cache. Subsequent visits. Cache hit. On subsequent visits, the browser checks its cache to see if the requested asset is already stored. If it is and the caching rules are still valid, the browser retrieves the asset from the cache instead of sending a new request to the server. Validation. If the caching rules require validation, example the asset has an e-tag or last modified header, the browser sends a conditional request to the server, using if none match or if modified since headers. Server response 304 not modified. The server responds with a 304 not modified status code if the asset hasn't changed since the last time the browser requested it. The browser then uses the cached version. Server response 200 OK. If the asset has changed, the server responds with a 200 OK status code and the updated asset content. The browser updates its cache with the new version. 2. Cache location. Browsers use a hierarchy of caches. Browser cache private to each browser instance. Proxy caches shared by multiple users, example an ISP's proxy server. 3. Types of assets to cache. Ideally, you want to cache static assets, meaning those that don't change frequently. Common candidates include images, JPG, PNG, GIF, SVG. CSS style sheets. JavaScript files. Asterisk fonts, WOFF, TTF, OTF. Asterisk videos, MP4, WEBM. Important HTTP headers for caching. These headers are the key to controlling browser caching. Asterisk cache control, this is the most important header, and it provides a general mechanism for controlling caching behavior. It offers a range of directives. Asterisk public indicates that the response can be cached by both browsers and intermediate caches, example proxy servers. Asterisk private indicates that the response is intended for a single user and should not be cached by shared caches, example proxy servers. Use this for user-specific data. Asterisk maxage equals seconds specifies the maximum time, in seconds, that a resource is considered fresh. After this time, the browser must revalidate the resource. Asterisk smaxage equals seconds, similar to maxage, but it applies only to shared caches, example proxy servers. If both smaxage and maxage are present, smaxage takes precedence for shared caches. Asterisk no cache forces the browser to revalidate the resource with the server before using it from the cache. The browser still caches the resource, but it always checks with the server first. Asterisk no store prevents the browser from caching the resource at all. Asterisk must revalidate specifies that the cache must always revalidate the resource with the server before using it, even if the resource is still fresh according to its max age. If validation fails, the cache must return an error, 504 gateway timeout. Asterisk immutable indicates that the resource will not change for the lifetime of the cache. This is particularly useful for assets with version numbers in their file names. Asterisk stale while revalidate, the cache can return a stale response while it revalidates in the background. Asterisk expires specifies the date and time after which the response is considered stale. This is an older header, and cache control, maxage is generally preferred because it's more flexible and relative to the request time. Asterisk etag, a unique identifier for a specific version of a resource. The server generates the etag, typically a hash of the content. The browser sends the etag back in the if none match request header when validating the cache. Asterisk last modified, the date and time the resource was last modified on the server. The browser sends the last modified value back in the if modified since request header when validating the cache. Asterisk vary specifies which request headers the server used to decide which version of the resource to serve. For example, if you serve different content based on the accept encoding header, for zip compression, you should include vary accept encoding in the response. This ensures that the browser caches different versions of the resource based on the value of accept encoding. Caching strategies and best practices. 1. Long-term caching with versioning, cache busting. Asterisk the most effective strategy for static assets is to set a very long cache control, max age value, example 1 year, and then invalidate the cache whenever the asset changes. You can do this by adding a version number or a content hash to the file name. Asterisk example. Asterisk instead of style.css, use style.v1.css or style.updef12345.css. Asterisk when you update the style sheet, change the file name to style.v2.css or style.yavuxi67890.css. Asterisk the browser will treat the new file name as a completely different resource and download it, while still keeping the old version in the cache in case it's needed by older pages. 2 conditional requests, etag and last modified. Asterisk for resources that change frequently, use etag or last modified to allow the browser to efficiently validate the cache. Asterisk if the resource hasn't changed, the server can respond with a 304 not modified status code, saving bandwidth. 3. Zip compression. Compress your assets using zip or .li compression to reduce their size and improve download times. Ensure that your server is configured to serve compressed assets and that you include the vary, except encoding header in the response. 4. Content Delivery Network, CDN. Use a CDN to distribute your assets to servers located closer to your users. This can significantly reduce latency, especially for users located far from your origin server. 5. Consistent hashing. If you're using a CDN, configure it to use consistent hashing for cache keys. This ensures that assets are cached more efficiently and that cache invalidation is more predictable. 6. Cache control recommendations. Static assets, images, CSS, JavaScript cache control, public, max age equals 3153600, immutable, for versioned assets. HTML, often dynamic cache control, public, max age equals 3600, must revalidate, or shorter max age if it changes more often. User specific data cache control, private, max age equals 0, must revalidate, or no store if you don't want it cached at all. Always revalidate cache control, no cache. Code examples, setting cache headers. Here are examples of how to set cache headers in various server-side languages. 1. Node.js, Express. Explanation We use Express static to serve static files from the public directory. The max age option sets the cache control, max age header for all files in the public directory. The setHeaders function allows us to customize the headers for specific files. In this example, we set different cache control headers for CSS/JS files and HTML files. 2. PHP. Explanation We use header to set the cache control header based on the file extension. We also set the content type header to ensure that the browser interprets the file correctly. 3. Python, Flask. Explanation The send_from_ directory function in Flask is used to serve static files from a directory. The cache_timeout argument sets the cache control, max age header. We can also pass a headers dictionary to set additional headers. 4. Apache.access. You can configure caching directly in your apache.access file. Explanation The files match directive allows you to apply caching rules to specific file types. The if module mod_headers.c block ensures that the header directive is only used if the mod_headers module is enabled. 5. Inks, configuration file. Explanation The location blocks specify the file types to which the caching rules apply. The expires directive sets the cache control, max age header, using a date-based syntax in Inks. The add_header directive adds the cache control header. Debugging and testing caching. 1. Browser developer tools. Use your browser's developer tools, usually accessed by pressing F12, to inspect the HTTP headers for each request and verify that the caching headers are set correctly. The Network tab is your best friend here. Look at the size column. If it says, from cache, the asset was served from the browser cache. 2. Online tools. Several online tools can help you analyze your website's caching configuration. Examples include Web Page Test, https://www.webpagetest.org. Jeet metrics, https://gtmetrix.com. Page speed insights, https://developers.google.com/speed/pagespeed/insights. Common pitfalls. Forgetting to version assets. If you update an asset without changing its file name, the browser may continue to use the cached version. Inconsistent caching. Make sure you're setting caching headers consistently across all your assets. Overly aggressive caching. Be careful not to cache dynamic content that changes frequently. Ignoring vary header. If you serve different content based on request headers, example accept encoding, make sure you include the vary header. Not using zip compression. Zip compression can significantly reduce the size of your assets, improving performance. Example scenario, caching a JavaScript file. Let's say you have a JavaScript file named app.js. You want to cache it for 1 year and invalidate the cache whenever you update the file. 1. Initial deployment. Rename the file to appv1.js. Set the following cache control header, cache control, public, max age equals 315360000, immutable. 2. User visits the page. The browser downloads appv1.js and caches it. 3. You update the JavaScript file. Rename the file to appv2.js. Update your HTML to reference appv2.js. 4. User revisits the page. The browser sees that appv2.js is a new file and downloads it. The browser still has appv1.js in its cache, but it's not used because the HTML now references appv2.js. Conclusion. Browser caching is a critical optimization technique for web performance. By understanding how it works, using the right HTTP headers, and implementing effective caching strategies, you can dramatically improve the speed and responsiveness of your website, resulting in a better user experience and reduced server load. Remember to regularly test and monitor your caching configuration to ensure that it's working as expected. Experiment with the different cache control directives to find the optimal balance between caching and freshness for your specific website.